Hi friends, welcome to puzzle 10 coin stacks. In this puzzle you are given 10 stacks of coins, 9 of which contain genuine coins, 1 stack contains fake coins. The genuine coins weigh 10 grams and fake coin weighs 11 grams. We also have a scale here. You can use the scale to measure these weights of the coins to know which coin is a genuine coin and which coin is a fake coin. What is the minimum number of weighings needed to be done to identify the fake coins? Okay. Well, there's a small calculation here that I've done just for some brief analysis. That the total weight of coins is 900 grams and the total weight of fake coins is 110 grams. However, let's come back to the problem. So the problem is the minimum number of weighings you need to do. Okay, so some say we will have to do at least 5 weighings, because if I start weighing every 2 groups and I take these groups and I take one coin from this group and one coin from this group and I weigh them on the scale to find out they are balanced. So I'll move on to this one, move on to this one, move on to this one, and say now I know that there is some problem and this one is the one. Okay, so if I do a group of 3, 4 and 5, so in this case you will have to do at least 5 comparisons to know for certain which coin it is. So what we can do instead of this is we can group these coins. So we can group these 2 coins and these 2 coins, these 2 coins, these 2 coins and these 2 coins, and then we can measure them in groups. So when we find out all the groups are balanced except for these 2 groups, then we know that the coin belongs to fake coin belongs to this group, because this will weigh heavier than the earlier one, right? So how many comparisons did it took you? So this took me 1 comparison, this took me 2 comparisons, this took me 3 comparisons, and then I had to do one more comparison to find out which one of them was fake among this one. So in total we can reduce it to 4. Can we reduce it further? Let's try to group them into 3 instead of 2. So now I have group 1, group 2, group 3, and that's it. We can let the other go. So we can do these 3 comparisons. If all of them are balanced, we would know for sure that the last one is the one with fake coins. If say in this case we did comparison of this one and this one comparison, find out they are balanced, and then we do this comparison and this comparison, second comparison, to know that the fake coin belongs to this group. So 2 comparisons till now, and now we just have to find which one is the fake stack. So now we can do 2 groups each and we can compare them. So this will be one more comparison, and say I compare this and this, so I'll know fake coin belongs to this or fake coin belongs to this. Okay, so I don't have to do 2 comparisons here. I can just pick randomly any 2 groups. If I pick this, I know which is my fake stack. If I pick this and this, I know which is my fake stack because these are balanced. If I do this and this, then also I know which is. So I have to do only 3 comparisons if I go by this approach. 3 groups, and then into 2 groups. Right? Can we reduce it further? Maybe. Let's try. Say I don't group them into 3 but 4. So I have 1 group and 2 group. One group, 1, 2, 3 and 4, and 1, 2, 3 and 4. Okay, so I weigh them. If they are equal, then I know it's here. So I compare 1 and I compare 2, and then I know for certain. And if in this case these two groups will not balance, so I know that it belongs to this group. So then again I have to do another comparison between this 2 and this 2, and then I'll know this one, and then I'll have to do this one and this one. So this is 3. So now what we can do, how I can group this further, say we can do 3 and 3. Okay, so what we can do is we can just take 2 and 2, and then we can see what is the weight of this, and then we can further down it, or we can just pick 1 or 2 and we will know it belongs to this. So I think you cannot reduce it less than 3, because in any case we'll have to do at least 3 comparisons. So that is my correct answer. Thank you very much for listening.